Hello everyone, welcome to another math video. I'm Professor Diwa, and in this video we'll be going over systems of linear equations and problem solving. Our objectives are to solve problems that can be modeled by systems of 2 linear equations, solve problems that can be modeled by systems of 3 linear equations. Alright, so let's get started. For example number 1, America's consumption of red meat has decreased most years since 1980. Whole consumption of poultry has increased. The function y equals negative 0.59x plus 124.6 approximates the annual pounds of red meat consumed per capita, where x is the number of years since 1980. The function y equals 1.34x plus 40.9 approximates the annual pounds of poultry consumed per capita, where x is also the number of years since 1980. If this trend continues, determine the year in which the annual consumption of red meat and poultry is equal. To determine the year in which the annual consumption of red meat and poultry is equal, we just take the equation for the consumption of red meat and set it equal to the equation for the consumption of poultry. We get negative 0.59x plus 124.6 equals 1.34x plus 40.9. Next, we go ahead and simplify this equation. I'm going to get rid of the negative 0.59x by adding it to both sides of the equation. I'll also get rid of the 40.9 by subtracting 40.9 from both sides. Simplifying the left-hand side, negative 0.59x plus 0.59x cancels out. 124.6 minus 40.9 is 83.7. On the right-hand side, 1.34x plus 0.59x is 1.93x. 40.9 minus 40.9 cancels out. The result is 83.7 equals 1.93x. From here, we get rid of the 1.93 by dividing it out on both sides. We get 83.7 divided by 1.93 equals 1.93x divided by 1.93. Simplifying the left-hand side, 83.7 divided by 1.93 gives us the decimal value 43.3678, and this decimal value keeps on going. On the right-hand side, 1.93x divided by 1.93 simplifies to just x. The result is x equals 43.3678, and this decimal value keeps on going. For this problem, I'm going to round our decimal value to the nearest whole number, which is 43. This means that the consumption of red meat and poultry will be equal 43 years after 1980, or in the year 2023. For example number 2, a Boeing 747 jet flies 4 hours west with a 60 miles per hour tailwind. Returning against the wind takes 5 hours. Find the speed of the jet with no wind. This is what we call a uniform motion problem, which utilizes the distance equals rate times time formula, or d equals rt for short. We'll also use the chart here to help us construct the equations we need to solve this problem. In the chart, we have 2 rows, 1 row for with the wind and 1 row for against the wind. We have 3 columns, 1 for the rate, the time, and then also 1 for the distance. Starting off with the column for time, we know that when we're going with the wind, the travel time for the jet is 4 hours. When we're traveling against the wind, the travel time takes 5 hours. It's implied in this problem that the distance is the same. The jet starts off at its point of origin, traveling west to its point of destination. Afterwards, it returns back to its point of origin, which implies that the return trip is the same distance. We don't know what the distance is, but we can just represent it with the variable d. Next, we need to come up with the rate. When the plane is traveling to its destination, it's traveling with the wind. This means that the wind is pushing the plane, making it go faster. We don't know the rate of the plane, so we're going to represent it as r. We know that the rate of the wind is 60, and it's making the plane go faster. So that means that we add together the two rates. So the rate for traveling with the wind is r plus 60. Now when the plane is traveling back to its point of origin, it's traveling against the wind. This means that the wind is making the plane go slower. So the rate of the plane is r, and the rate of the wind is 60, and we just subtract the two. So we get r minus 60, or the rate of the plane traveling against the wind. Next, we need to come up with two equations. The first equation we get from the row with the wind. The second equation we get from the row against the wind. All we need to do is just multiply the rate times the time and set it equal to the distance. So for the row with the wind, we get 4 times the parentheses r plus 60 close parentheses equals d. And for the row against the wind, we get 5 times the parentheses r minus 60 close parentheses equals d. Now that we have our two equations, there's two different ways we could solve this. We could use the substitution method or the elimination method. Since both equations are set up for substitution, it's better to use the substitution method. Since both equations are solved for d, we just need to set them both equal to each other, simplify, and then solve for the variable r. So we have 4 times the parentheses r plus 60 close parentheses equals 5 times the parentheses r minus 60 close parentheses. From here we go ahead and simplify by distributing the 4 inside the parentheses to the r in the 60, and we distribute the 5 inside the parentheses to the r in the minus 60. When we do the distribution for both sides, we get 4r plus 240 equals 5r minus 300. From here we can do two steps at once. I'm going to get rid of the 4r by subtracting it from both sides, and I'll get rid of the minus 300 by adding it to both sides. Simplifying the left-hand side, 4r minus 4r cancels out. 240 plus 300 is 540. On the right-hand side, 5r minus 4r is r. Minus 300 plus 300 cancels out. The result is 540 equals r. So this tells us that the speed of the jet with no wind is 540 miles per hour. In example number 3, two cars leave Indianapolis, one traveling east and the other west. After 3 hours, they are 297 miles apart. If one car is traveling 5 miles per hour faster than the other, what is the speed of each car? Again, we have a uniform motion problem, so we're going to use the distance formula d equals rt. So here I have a table with 2 rows and 3 columns. For the first row, this represents the car going east. The second row represents the car going west. The first column is the rate, the second column is the time, and then the third column is the distance. So let's go ahead and fill in some information in the table. The problem stated that after 3 hours, the cars are 297 miles apart. So we know the travel time for both cars going east and west is just 3 hours. Next, let's try to fill in the rate. We know that one car is traveling 5 miles per hour faster than the other, and we don't have any other information. So let's just say that the car going west is traveling at a rate r. That means the car going east will be 5 miles per hour faster than the rate of the car going west. We could just write r plus 5. Next, we need to come up with the distance. So here I have a diagram of both cars traveling in opposite directions. The starting point here is Indianapolis. After 3 hours, the cars stopped, and the distance apart from both cars is 297 miles. Now we don't know the distance that each car traveled. This is what we're trying to find. So I'm going to represent the distance of the car going east as d. That means that the car that went west traveled a distance that is equal to 297 miles minus d. So we could go ahead and put that information in our chart. Next, we could find the equation for both cars. We just multiply the corresponding rate and time and set it equal to their distance. For the car going east, we get 3 times the parentheses, r plus 5 close parentheses equals d. For the car going west, we have 3 times r equals 297 minus d. Next, we could solve this problem using substitution or elimination. However, again, this problem is set up for substitution. So what I'm going to do is I'm going to substitute my value for d from the car going east into the equation for the car going west. We get 3r equals 297 minus 3 times the parentheses r plus 5 close parenthesis. From here, we could distribute the minus 3 into the parentheses to the r and the plus 5. When we do the distribution, we get negative 3r minus 15. We could bring down the 297 and the 3r on the left-hand side. We get 3r equals 297 minus 3r minus 15. Next, we could combine like terms on the right-hand side. We have 297 minus 15 is 282, and we could bring down the minus 3r. On the left-hand side, we bring down the 3r. The result is 3r equals 282 minus 3r. From here, we could get rid of the minus 3r by adding 3r to both sides of the equation. Simplifying the left-hand side, 3r plus 3r gives us 6r. On the right-hand side, minus 3r plus 3r cancels out, and we bring down the 282. The result is 6r equals 282. From here, we get rid of the 6 by dividing both sides by 6. We get 6r divided by 6 equals 282 divided by 6. Simplifying the left-hand side, 6r divided by 6 is r. Simplifying the right-hand side, 282 divided by 6 is 47. The result is r equals 47. So this means that the rate of the car going west is 47 miles per hour. Next, we need to find the rate of the car going east. The rate of the car going east is equal to r plus 5. We substitute our value for r, which is 47. We get 47 plus 5 is equal to 52. So the speed of the car going east is 52 miles per hour, and the car going west is 47 miles per hour. In example number 4, a chemistry student is asked by his instructor to prepare 90 liters of 6% hydrochloric acid, or HCl. The student only has a bottle of 3% HCl and a bottle of 8% HCl. How much of each bottle should be mixed so that the instructor has the required solution? Now, this type of problem is what we call a mixture problem. It's also referred to as a total value problem because we need to use the total value equation, which is quantity times value equals total value. Now, for this application, our quantity is the number of liters, our value is the concentration, which is value per liter, and then the total value is just the total amount that is required. To help set up this problem, I'm going to use this table, which has 3 rows and 3 columns. The first row is the number of liters, the second row is the concentration, which is value per liter, the third row is the total amount of pure HCl. Our first column represents the bottle of 3% HCl, the second column represents the bottle of 8% HCl, and the last column is the total 6% HCl that is needed. Alright, so let's start filling in the table. According to this problem, we need to figure out how many liters of each bottle should we mix so that we can get the required solution. That means that we don't know the number of liters for each bottle to mix together. So I'm going to use X to represent the number of liters that we need for 3% HCl, and I'll use Y to represent the number of liters we need for 8% HCl. Now the instructor is asking for 90 liters of 6%, so this is the total amount of liters that we need. Next, we can go ahead and fill in the concentration for each of the columns. So for the 3% HCl, this is just 3%. We write it as a decimal, so this is 0.03. For the 8% HCl, we write this as 0.08, and the total needed is 6%. We write this as 0.06. Next, we could fill in the total amount of pure HCl for each of the columns. So for the 3% HCl, we just multiply the number of liters times the concentration. So we just get 0.03x. For the 8% HCl, we get 0.08y. And then for the total amount needed, we just multiply 90 times 0.06, we get 5.4. Next, we get our first equation from the first row, which represents the total number of liters. So we have x plus y equals 90. We get our second equation from the last row, which represents the total amount. We have 0.03x plus 0.08y equals 5.4. From here, you could see we have two equations with two variables, so we could solve them using substitution or elimination. In this case, I'm going to use elimination because both of our equations are written in standard form. The first thing I'm going to do is get rid of the decimals in the second equation by multiplying both sides of the equation by 100. So I have 100 times the parentheses 0.03x plus 0.08y close parentheses equals 100 times 5.4. After doing the multiplication, the result is 3x plus 8y equals 540. From here, I'm going to choose to eliminate the x variable. If you look at the x variables from both of the equations, we have 3x and then x. So what I need to do here is change the x from the first equation to negative 3x. To do this, we just multiply the first equation by negative 3. So I have negative 3 times the parentheses x plus y close parentheses equals negative 3 times 90. After doing the multiplication, the result is negative 3x minus 3y equals negative 270. Now we can add the two equations together and eliminate the x variable. We have negative 3x plus 3x cancels out, minus 3y plus 8y is 5y, negative 270 plus 540 is 270. The result is 5y equals 270. From here we get rid of the 5 by dividing both sides by 5. We get 5y divided by 5 equals 270 divided by 5. Simplifying the left-hand side, 5y divided by 5 is y. On the right-hand side, 270 divided by 5 is 54. The result is y equals 54. From here, we need to solve for the x variable. To do this, we just take our value for y, and we could substitute it either into our first equation or second equation. I'm going to use the first equation, x plus y equals 90, because it's a lot easier to do calculations with. So we substitute in 54 for y. We get x plus 54 equals 90. Next, we need to solve for x by getting rid of the 54. We just subtract 54 from both sides of the equation. Simplifying the left-hand side, 54 minus 54 cancels out. We bring down the x. On the right-hand side, 90 minus 54 is 36. The result is x equals 36. So this means in order to prepare 90 liters of 6% HCl, the student needs to mix 36 liters of 3% HCl and 54 liters of 8% HCl. For example number 5, the measure of the largest angle of a triangle is 80 degrees more than the measure of the smallest angle, and the measure of the remaining angle is 10 degrees more than the measure of the smallest angle. Find the measure of each angle. For triangle problems, it's important to know that the sum of all angles inside of a triangle is 180 degrees. So for this problem, the first thing we need to do is come up with an equation for the small angle, the medium angle, and the large angle. If we reread the problem, it states that the measure of the largest angle is 80 degrees more than the measure of the smallest angle, and the measure of the remaining angle is 10 degrees more than the measure of the smallest angle. Notice here they didn't tell us any information about the smallest angle. That means we'll use x to represent our smallest angle. Now the largest angle is 80 degrees more than the measure of the smallest angle. We could represent this as x plus 80. And the medium angle is 10 degrees more than the measure of the smallest angle. So this will be x plus 10. Next, we're going to use the fact that the sum of all angles inside of a triangle is 180 degrees. So if we add together the small angle, the medium angle, and the large angle, this is equal to 180. Next, we substitute the value for each angle inside our equation. We get x plus 10 plus x plus 80 equals 180. From here, we could combine like terms on the left-hand side. We have x plus another x is 3x. We have 10 plus 80 is 90. So the result is 3x plus 90 equals 180. Next, we can get rid of the 90 by subtracting 90 from both sides. On the left-hand side, 90 minus 90 cancels out, and we bring down the 3x. On the right-hand side, 180 minus 90 is 90. The result is 3x equals 90. From here, we get rid of the 3 by dividing both sides by 3. We get 3x divided by 3 equals 90 divided by 3. Simplifying the left-hand side, 3x divided by 3 is x, and on the right-hand side, 90 divided by 3 is 30. The result is x equals 30. So that means that my small angle is equal to 30 degrees. For our medium angle, this is x plus 10. We just plug in 30 for x. We get 30 plus 10 is 40. And our large angle is equal to x plus 80. So we substitute in 30 for x. We get 30 plus 80 equals 110. Our final answer is that the small angle is 30 degrees, the medium angle is 40 degrees, and the large angle is 110 degrees. Alright, so this is the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.